The last form of reasoning we'll discuss is called deductive reasoning. And here we're going to deduce whether some conclusion is true based on some premises that precede it. So that's what we do in this case. We evaluate the soundness of a conclusion, assuming that there are certain premises, some statements that are assumed to be true. And then what we look at is, if these premises are true, does the logic itself actually follow, and is the conclusion true if the premises were true? This is not to say that the premises are necessarily true, it's just whether the argument actually logically follows or not. So I think this will become more clear if I give you a couple of examples. So for example, imagine we have two premises. First one states that all Porsches are reliable, and the second one states that the Boxster is a Porsche. From that, it logically follows that the Boxster is reliable, because a Boxster is part of all Porsches, and if all Porsches are reliable, then it follows that the Boxster is reliable. So in this case, we have two premises that may or may not be true, but either way, the conclusion logically follows from those premises. To tell you the truth, I don't know if Porsches are in fact reliable or not. Deductive reasoning really looks at just at the level of the structure of the argument, and given that the premises are correct, would the conclusion logically follow or not? These are called syllogisms, these structures where you have two premises and then a conclusion. And so syllogism is basically just any sort of setup where you have two different premises and then a conclusion and whether it follows or not. So to show you that it's not always the case that the premises must be true, that it's really at the level of formal logic, right? Look at this example. All professors are jerks. Dr. Van der Waal is a professor, therefore Dr. Van der Waal is a jerk. I mean, of course, that can possibly be true, but at the level of logic, this is absolutely a sound argument, right? If it were the case that all professors are jerks, and if I am a professor, then it would imply that I must be a jerk, okay? So it's really at the level of the logic itself. These syllogisms happen in a couple of different ways. Some of them are called categorical syllogisms, and they deal with membership to a certain category. So for example, all A's are B's, or all professors are jerks. C is an A. Dr. Van der Waal is a professor. Therefore, C is a B. Dr. Van der Waal is a jerk. Okay? So you see here it's replaced with A, B, and C just because A, B, and C can be anything, right? All cows are dumb. Betty is a cow, therefore Betty is dumb. It could literally be anything you can think of. There's also conditional syllogisms that have a slightly different form. They express themselves in if-then statements. So for example, if a car is a Porsche, then it is reliable. The Boxster is a Porsche, therefore the Boxster is reliable. Okay, that's a conditional syllogism. So if it is the case that such and so, then such and so follows. Now you see that, of course, these are simplified examples, but it's useful to have some notion of these sorts of structures and rules of logic when you're actually engaging with somebody in a debate. There's two things you can do when you're trying to argue a point with somebody. First of all, you need to see if you actually agree with the premises that they're stating or not. That's one possibility, right? Maybe they come up with a premise that you don't actually believe to be true. So of course you can then have a discussion about that. But then even if the premises are true, then the next question is, from those premises, does the conclusion actually logically follow? So to give you a recent example, right? I mean, Donald Trump not so long ago claimed that Mexicans were rapists. So it would look something like all Mexicans are rapists if Juan is a Mexican, therefore Juan is a rapist. Now, if that were the argument, at the level of logic that would be correct, but at the level of the premises, this is of course complete mumbo jumbo. It's absolutely not true at all. Okay? So to tackle that argument, you can really look at the validity of the premises, and then if the premises are true, then you can look at whether the conclusion is actually warranted based on those premises. And if either of them is false, right, either the premises are false or the conclusion doesn't follow, then it's really not a good argument altogether. So Let's look at this from the perspective of what's called a Venn diagram. There's a couple of different things here. Let's say we have a statement like all A's are B's. All professors are jerks. What that can mean is the following. Let's say A is the group of all professors, B is the group of all jerks, and it happens to be that there's no jerks that are not professors and there's no professors who are not jerks. So the two circles are exactly identical to each other. They're just one and the same thing. Another possibility is that you have a large group of jerks. You see the circle for B is all the jerks in the world. And the group A, professors, every single one of them happens to fall within that group of jerks. But there's also jerks who are not professors. Right? So in other words, the statement all A's are B can be drawn in two different ways. Either it means that all B's are also A's. Doesn't have to be the case though. It could also be that A is a subset of all the B's. Universal negatives are easier. No professors are jerks. So that's easy. We got a circle of B over here with all the jerks, and the circle of A is completely separate because the professors are not jerks at all. There's no professor who is a jerk. The two are not overlapping whatsoever. These are the two straightforward cases. Now it gets more complicated quickly, right? Let's look at the argument some A's are B. So some professors are jerks. Okay, we can draw that in all sorts of ways. Here's the group of jerks, and some of the professors overlap so that they're both professors and jerks. It could in fact mean that all professors are still jerks. This is also consistent with some are jerks. All of them are. It can even be the case that there's more professors than that are jerks, and in reality all the jerks are actually professors, but this complies with the statement some A's are B. Or it could again be that the two of them are actually exactly the same. Every single jerk is a professor and every professor is a jerk. So in this case, any statement like some A's are B, logically speaking, to then deduce what follows from that becomes very much more complicated because there's different ways of actually depicting that. Particular negatives are also slightly trickier. Some A's are not B, right? So here some professors are not jerks. Some of them are outside of circle B. It could also mean that there are no professors who are actual jerks, right? All of them are outside of it. Or it could in fact even mean that all the jerks are professors, but there's still some professors who are not jerks. So you see again there, it's more tricky. So let's practice with this and see if we can actually have this help us figure out whether arguments are logically following or not. So let's imagine the following two premises. No physical actions are chance occurrences, so no A's are B's. All chance occurrences are surprising events, so all B's are C's. Therefore, no surprising events are physical actions. Okay, so you can draw this out. We have three circles here. The first circle of no physical actions is apparently the physical action circle is not overlapping with any chance occurrences. So let's look at that first. So here we have the circle for physical actions. Here we have the circle for chance occurrences. Those are not overlapping. All chance occurrences are surprising events. So here we have the circle for surprising events, and every single one of the chance occurrences falls within it. Does it follow then that no surprising events are physical actions? No, it does not, because it's not saying that it's not possible that there are some surprising events that are actually not chance occurrences, right? It might be that the circle for surprising events is way larger. In fact, it could be so large that it includes every physical action as well. So by drawing this out, you can easily show that this is actually not a logically sound conclusion. Regardless of whether these premises are true or not, from these premises we cannot deduce that this conclusion is actually correct. Here's a second one. All events are things describable by science. So what this tells us is that there's a circle for all events, and it's within the circle for science. All mental decisions are events. So this tells us there's a circle for mental decisions that is within the circle of events. And again, remember the circle of events is inside the circle of science. Therefore, all mental decisions are things describable by science. There's only one way to draw this out, right? Here's all the things describable by science. Some of them are all of the events are inside of that, and inside of all of the events are also the mental events. So all mental events are describable by science. Yes, that's correct. I understand that this is not the most straightforward thing you've ever heard. So if you need to go over this a couple of times, I understand. Okay, the point here is to see whether you can use these Venn diagrams to draw it in a way that actually would violate the conclusion. The second you can violate it or draw it in a way that violates the conclusion, then it means that it's not a logically sound argument. All right, I have two more. All things describable by science are predictable events. No free decisions are things describable by science. So in other words, we have a circle for things describable by science. They're part of predictable events. Free decisions are separate from things describable by science. Therefore, no free decisions are predictable events. That is not the case. In fact, it could be that the circle for predictable events includes all things describable by science. It could even mean that every single free decision is even within that predictable event circle. So that is not logically sound. It does not have to follow. Last one, no things describable by science are unintentional. So no A's are B. All mental decisions are things describable by science. So no A's are B. All C's are A. Therefore, no C's are B. Well, let's see if that's true or not. Right? So we have things describable by science separate from unintentional things. The second premise tells us that all mental decisions are things describable by science, so the mental decision circle has to be within the things describable by science. Therefore, no mental decisions are unintentional. Yes, that is the case, because this small circle of mental decisions has to be within the circle of things describable by science, and we've been told that there's no things describable by science that are unintentional. So this is a logically sound argument.